Hello there, and welcome to the Sleepless Scientist, a quiet little corner of the cosmos where thoughts can drift, curiosity can rest its head, and knowledge moves softly, like moonlight across a still lake. Tonight's journey will guide us into the hidden structures beneath everything we see and touch, the gentle forces and delicate frameworks that hold reality together, even when we're not looking. Our topic this evening is decoding reality's fabric, unseen forces shaping existence. But before you settle in and get cozy, I'd love to ask you a small favour. If you find these calm explorations soothing or helpful, feel free to give this video a like and subscribe, only if it feels right for you. And if you're awake enough, you can leave a comment telling me where in the world you're listening from and what time it is in your corner of the night. It's always quietly magical to imagine this community stretching across time zones, from the soft blue dawn in one city to the deep velvet night in another, all connected by a shared curiosity. Now, wherever you are, maybe stretched out beneath a warm blanket, or resting on a favourite sofa, or simply letting your breath fall into a gentle rhythm, I hope you're comfortable. Perhaps the lights are dim, perhaps the room is still, and perhaps even the air feels a little softer somehow. If your mind begins to wander along the way, don't worry, let it drift. We'll still be here, unfolding these ideas slowly and calmly. Tonight, we begin with something familiar, the world as we think we know it, the hard surfaces, the quiet objects resting around us, the reassuring solidity of the everyday. But underneath that comfort lies a deeper story, one where matter becomes spacious, where vibrations stand in for substance, and where the universe reveals far more room inside itself than we ever imagined. When you're ready, let's gently begin. If you stretch out your hand and touch the surface beside you, maybe a pillow, or the edge of the mattress, or the cover of a book, it feels firm, safe, and satisfyingly real. Solidity is one of the quiet certainties of daily life. Wood feels solid, stone feels solid. The floor beneath your feet feels stable and unmoving. But if we slow down, if we step just a little closer to the true fabric beneath that familiar surface, the certainty begins to loosen. Not in a frightening way, but gently, like a curtain being pulled aside to reveal a wider view. At the smallest scales, matter is far less like a solid wall, and far more like a grand cathedral with towering empty halls. Every object around you, no matter how sturdy, is built from atoms, tiny structures that are mostly open space. The nucleus, so small it is almost unimaginable, sits at the centre like a quiet lantern, while the electrons swirl far around it, their distance breathtaking when compared to their size. If an atom were as large as a cathedral, the nucleus would be a grain of sand floating in the middle, and the electrons would be like faint drifting fireflies, moving so quickly they blur into a soft cloud. And yet, when you place your hand on a surface, none of this empty space is felt. Your fingers meet resistance, not because the atoms inside the object are packed tightly like marbles in a jar, but because the fields surrounding those atoms refuse to let your atoms pass through theirs. It is not substance pushing back, but something quieter and stranger, a gentle repulsion between invisible layers of electric charge. Solidity, in the simplest sense, is the soft but firm handshake of two clouds of energy. Even the particles themselves, the ones we imagine as tiny spheres, aren't really little balls at all. They behave more like notes played on a hidden instrument. Each particle is a vibration, a small ripple in an invisible field that fills all of space. Instead of thinking of matter as building blocks, it may help to picture it as music. A chair, a stone, the pillow beneath your head. They are melodies, each made of countless trembling notes woven together. Some vibrate quickly, some slowly, some resonate with others. The world becomes less a warehouse of objects and more a symphony of patterned motion. And then, deeper still, this seemingly empty space between and around all of this is not empty either. Even when everything grows quiet, even when the temperature drops toward absolute stillness, space continues to shimmer with tiny fluctuations, brief sparks of energy that appear and vanish too quickly for the eye to see. These are the smallest stirrings of the quantum world, little flickers that never fully rest. You can picture them as minuscule ripples sliding beneath the calm surface of a lake at night, their presence felt not in sight, but in the way they gently tug on what floats above. All of this means that what you call touch is not contact in the usual sense. No atom in your body ever truly touches an atom in the object beside you. Instead, your fields brush against its fields, like two dancers moving close enough to feel the warmth of one another without ever colliding. The sense of pressure you feel is your nervous system's interpretation of this closeness, a translation that gives your experience stability and comfort. In a way, your senses are storytellers, crafting a version of the world that helps you navigate through it without overwhelming you with invisible complexity. If your eyes could see the empty space inside matter, or the trembling beneath every particle, or the quiet flicker of fluctuations in the vacuum, the world might appear too open, too fluid, too strange to walk through confidently. So your perception narrows the universe into something calm, solid, and familiar. Yet, knowing the deeper structure beneath that familiarity doesn't make reality less comforting. If anything, it can make the world feel more wondrous. To realize that the pillow under your head is a gentle choreography of energy, or that your hand glides across an ocean of spaciousness, can bring a slow, easy sense of awe. It means that everything around you is far more delicate and intricate than it seems, and that your existence is built upon subtle patterns shaped by forces you never have to think about. As we drift forward, we'll continue exploring this hidden world. For now, you might simply rest with the thought that solidity itself is an illusion, crafted from invisible conversations between fields. What feels firm is actually a dance. What feels solid is mostly space, and what you experience as touch is a quiet meeting of forces moving in harmony. If you imagine the universe as a vast silent room, you might picture it filled with stars, planets, dust, and drifting clouds of gas. But beneath all that, beneath every object, every atom, every point where light travels, there is something deeper and much more subtle. The universe is not built from solid things set against a backdrop of empty space. Instead, it is woven from fields, broad, continuous, invisible landscapes that stretch everywhere, even into the quiet air around you now. A field can feel like an abstract idea, so it may help to picture it gently. Imagine an endless ocean, its surface smooth and calm. Even on the calmest nights, that ocean is never perfectly still. Tiny ripples glide across it, dimples appear and vanish, and gentle waves shimmer through its surface. A field is something like that ocean, except instead of water, it is made of possibility, and instead of existing only where you expect it, it fills every corner of reality. There is a field for electricity, a field for magnetism, a field for light, a field for the particles that form your body, and one very special field that gives mass to everything you see. These fields overlap and interlace like layers of soft, shimmering fabric. When we talk about a particle, a tiny thing like an electron or a quark, we're not talking about a little bead or a grain of matter. Instead, we're describing a small, localized vibration in one of these fields, the way a single note rises from a guitar string. Each particle is a particular pattern of trembling. Every atom, every chemical bond, every breath you take is made from these tiny pulses in the fields beneath them. The universe is less a collection of objects and more a quiet concert of vibrations. Even the space that appears empty is alive with activity. If you could shrink yourself down until you were smaller than the smallest atom, smaller even than the smallest particle, and drift into the space between two atoms, you would not find a silent void. You would find motion, gentle, restless motion, tiny fluctuations that appear and disappear in an instant. Physicists sometimes call this the restless energy of the vacuum, but you can imagine it as the faint rustling of leaves in a forest at night. Subtle, but always there. These small flickers, these faint ripples in the fabric of space, have surprising consequences. For example, if you place two smooth metal plates extremely close together, the restless energy of the vacuum pushes them gently toward one another. It is as if the universe breathes between them, drawing them closer in a soft, quiet pressure. This is a real effect, measured many times, even though there are no particles travelling between the plates, no wind, no visible force. This subtle nudge comes purely from the way the fields beneath everything shift and ripple. The more we look, the more fields explain. The reason you feel weight on your mattress is because the field associated with mass bends the space beneath you. The reason your atoms resist falling through the bed is because the electromagnetic field refuses to let the fields that make up your body overlap with the fields that form the mattress. You're floating just above it, held up by tiny invisible pushes you never see. Even colour, the way a leaf looks green or the sky looks blue, comes from the way light interacts with these underlying fields. When a beam of light touches an object, it disturbs the fields inside that object. Some vibrations match, some do not. The ones that bounce back into your eyes create the colours you see, and the ones absorbed pass their energy deeper into the world. And then there is the quiet hum of the field that gives matter particles, often described in everyday language as a weight-giving mist pervading the universe. When particles move through this field, they push against it, like someone walking through waist-deep water. The more strongly a particle feels this field, the heavier it becomes. You never see this process directly, yet it shapes everything in your life, from the fall of an apple to the solidity of your bones. These fields do not start and stop. They do not belong to particular regions. They do not behave like tools stored in a box until someone pulls them out. They are everywhere, constantly moving, constantly influencing, constantly shaping the world in ways too small for us to witness. They flow under the surface of reality like gentle undercurrents, guiding the motion of everything above them. Your senses do not perceive these fields directly. You cannot feel them the way you feel the warmth of a blanket or the coolness of a glass of water. Your eyes are not tuned to their vibrations. Your ears cannot hear the quiet waves passing through them. And yet you live within these fields completely. You're shaped by them, held by them, lifted by them. Every thought in your mind, every breath you take, every heartbeat, every moment of your life unfolds inside this invisible ocean. It is a strange and soothing thought that everything you see is a kind of shadow cast by deeper movements you cannot sense. The world you experience is a translation, a gentle simplification, a kind of story your brain tells based on a small slice of what is truly happening. If your senses could expand, if you could perceive the fields directly, the world might shimmer with countless waves passing through one another, weaving patterns too delicate and intricate to describe. But perhaps it is enough to know that beneath every familiar surface, beneath the warmth of your blanket and the quiet of your room, there is a soft, unseen foundation supporting all of it. A fabric made not of threads, but of vibrations. A world that does not rest on solid ground, but floats on quiet patterns of motion. You are cradled by fields you cannot see, buoyed by forces you never feel, and carried by a universe that hums gently with hidden music. And as you rest with this thought, the idea that the world is made not of solid things, but of subtle waves, becomes less strange and more comforting, like discovering that the bed beneath you is softer than you first believed. When you open your eyes, the world arrives instantly. Colours bloom into view, shapes sharpen. The room you're in takes form as if waiting behind a curtain that lifts the moment you wake. Your senses offer such a steady stream of information that it's easy to believe they're showing you reality exactly as it is. But what you experience is something gentler and far more limited, a version of the world carefully shaped for survival, comfort, and clarity. Not the full truth, but a filtered, softened window. It can be helpful to imagine your senses as a set of finely tuned instruments, beautifully made but with narrow bandwidths. Your eyes detect only a sliver of the full spectrum of light. If the electromagnetic spectrum were stretched across a vast beach, the colours you see would be just a thin line in the sand, so small you might miss it entirely. Infrared light, ultraviolet light, radio waves, X-rays. They all wash through the world constantly, quietly, without ever brushing against your awareness. You move through these hidden waves every day, as unaware of them as a fish might be of the currents it swims through. Your ears also live inside a small window. They pick up vibrations that fall within a particular range, ignoring everything too slow or too quick. The walls around you hum with deep sounds you cannot hear. The air trembles with frequencies too fine or too rapid for your senses to notice. Even your skin translates only a narrow slice of the world's texture. The pressure of surfaces, the brush of wind, the warmth of a lamp. It does not feel the electromagnetic field swirling around your body or the tiny particles crossing through you every second, slipping by unnoticed. Your nervous system does not attempt to show you everything that exists. Instead, it offers you just enough information to navigate the spaces you inhabit. It selects what is useful and smooths away the rest. The result is a world that feels solid, stable, and cleanly outlined. Yet underneath this gentle version, the deeper reality is far more fluid. Particles shimmer into and out of existence. Fields ripple, tiny forces push and pull. The vacuum flickers. All of this unfolds below the threshold of perception. Imagine standing on a hill overlooking a city at dusk. You see the outlines of buildings, the glow of streetlights, the slow arc of cars moving down the road. Everything appears calm, steady, and complete. But inside each building are countless lives unfolding. Conversations, breaths, drifting thoughts, quiet moments, sudden joys. Beneath those again are the motions of atoms, molecules, and electrical signals racing through nerves. The simplicity you see from the hill is not wrong. It is simply one layer of a vast and intricate scene. Your senses operate the same way. They show you the skyline, not the 1,000 stories beneath it. Even your sense of time is shaped by the way your brain gathers information. Moments seem to flow smoothly, one after the other, like pearls sliding on a string. But underneath that steady flow, processes unfold that move at dramatically different speeds. Neurons fire in patterns too quick for conscious thought to register. Chemical reactions unfold in tiny fractions of moments. Out in the universe, stars age at a pace too slow for human eyes to detect, while cosmic rays zip past at nearly the speed of light. Your awareness gathers these wildly different rhythms and blends them into a gentle continuity, a pace you can live with. In this way, perception is like a painter who reduces the world into soft colours and clear shapes, simplifying complexities into something familiar. This simplification is not a flaw. It is a kind of gift, allowing you to move through life without being overwhelmed by the raw, turbulent fullness of reality. If you could see every vibration in a field, every fluctuation in space, every hidden wave of light, your senses would drown in detail. Instead, they create a usable map, an interpretation that offers clarity, not completeness. Sometimes, though, glimpses of the larger world slip through. When you stand near a speaker playing deep music, you may feel the vibrations through your chest. even though the sound itself dips below your hearing. When sunlight warms your skin, you feel the infrared glow even though your eyes cannot see it. When a storm approaches, you may sense the shift in pressure long before the first cloud darkens the sky. These moments remind you that your experience is just one channel in a much broader broadcast. Even your thoughts are shaped by these boundaries. The way you imagine objects, the way you remember events, the way you understand distance and depth, all are guided by the limited information your senses provide. When someone tells you that space is mostly empty, or that particles are waves, or that fields ripple through you constantly, your mind tries to match these ideas to the familiar shapes it knows. But reality is stranger than any everyday image can easily capture. And yet, with careful attention and a slow, gentle pace, you can start to feel the edges of that deeper world. One of the quiet beauties of science is that it helps reveal these edges. Through instruments that extend your senses, telescopes, microscopes, detectors, sensors, your perception stretches outward. You cannot see gravitational waves, but instruments can listen to them for you. You cannot see ultraviolet light, but telescopes can paint pictures from it. You cannot detect the ripples in quantum fields, but experiments can glimpse their effects. Each tool adds a new window, expanding the horizon of what you can imagine. Still, even with these tools, you will never perceive the full totality of existence. No one can. The universe is vast and layered, and human senses, no matter how extended, capture only a small fragment of its richness. But this is not a limitation to mourn. It is something quietly beautiful. The awareness that there is always more to discover, always more wonder resting just beyond the boundary of perception. For now, it may be enough simply to rest with the idea that what you see is only the surface of reality. Beneath it lies a world of fields, vibrations, hidden colours, and silent forces, an intricate shimmering tapestry that moves gently beneath your fingertips, even if you never feel it directly. And as we drift onward, we'll continue exploring how these unseen layers shape the world and how the cosmos speaks through signals too subtle for ordinary senses. If you could step outside the Milky Way and look back at it from the quiet dark between galaxies, the view would be breathtaking. A great spinning disk of starlight, spiraling arms curling outward like soft brush strokes, a glowing centre pulsing faintly with the combined warmth of countless suns. It would look delicate, almost fragile, as though the entire structure might unravel if touched. But the truth is the opposite. The galaxy is held together not by what you see, but by something you do not, an invisible structure cradling every star, every orbit, every drifting cloud of dust. The stars near the edges of the galaxy should, by all ordinary expectations, fly apart into the night. They orbit far too quickly. Their motion is more like leaves swirling in a storm than stones circling a distant anchor. If the galaxy were made only of the matter we can see, these outer stars would simply drift away. And yet they don't. They hold their course as if guided by a silent hand. That silent hand is what we call dark matter. Dark matter is not a single kind of object waiting to be found. It does not glow, reflect light, or absorb it. It does not form planets or stars. It does not burn or shine. In many ways, it is almost unimaginably quiet. And yet, this quietness carries incredible influence. Dark matter creates a kind of gravitational scaffolding, a hidden skeleton on which galaxies rest. You can think of it as a web of invisible beams holding the spiral, arms in place, keeping the stars from drifting away into the cosmic wind. When astronomers map the way stars move, they can trace these hidden beams. The stars follow the shape of something they cannot see, almost like iron filings arranging themselves around an unseen magnet beneath a sheet of paper. The paths they take reveal curves and hollows shaped by dark matter, a soft landscape carved into the fabric of space. But if dark matter cannot be seen directly, how do we know it's there? The answer comes from the way it bends light. When a distant galaxy shines across the universe, the light it emits travels along gentle curves shaped by gravity. If this light passes through a region filled with dark matter, it bends, sometimes only a little, sometimes enough to create arcs and stretches in the image we observe. It's as though the light has brushed against an invisible sculpture. We call this bending gravitational lensing. But you might imagine it as light gliding across the surface of a clear, curved river stone, its path shaped by something smooth and unseen beneath the water. By watching how light curves and how stars move, scientists can create maps of dark matter's distribution. These maps reveal an enormous cosmic structure, far larger and more intricate than the bright pinpoints of stars. Galaxies gather along strands of this invisible web, clustering where the web grows thick and drifting apart in vast empty spaces where the web grows thin. What we call the cosmic web is not made of galaxies themselves, but of the hidden threads of dark matter that created the framework on which galaxies later formed. The image can be soothing to imagine, a soft lattice stretching through the universe, like fine threads of silk laid across an enormous canvas. Along these threads, matter gathers, condenses, and slowly ignites into stars. Without this invisible architecture, the universe would be scattered dust, drifting in near-perfect stillness. There would be no galaxies, no clusters, no spirals, no stars swirling around their centres. And without stars, there would be no planets. And without planets, no quiet rooms, no warm blankets, no you. Even your own body is indirectly shaped by dark matter. Every atom in you was assembled in a star, and that star was gathered by the gravity of a dark matter halo, one of those invisible spherical cocoons that surrounds every galaxy. Without the guiding pull of dark matter, stars would never have gathered at all. They would not have lived, burned, or died. The heavy elements your bones are made from would never have formed. You are built from visible matter, but your story is rooted in the invisible. There is something gently humbling in this. The universe is structured not by the things we see, but by the things we do not. Reality itself rests on an unseen foundation, quiet and soft, yet unimaginably vast. Dark matter holds galaxies together the way the memory of a song holds its melody. Subtle, guiding, steady, unnoticed unless you listen closely. Scientists still do not know what dark matter is made of. It could be a new kind of particle, one that barely interacts with the particles we know. It could be a family of particles, or something even stranger, some delicate property of space itself that we have not yet imagined. But the lack of certainty does not make it less real. The wind, after all, was shaping forests long before anyone understood the idea of moving air. Sometimes the unknown can feel unsettling, but dark matter has a different kind of presence. It is not chaotic or dangerous. If anything, it is stabilizing. It is the quiet structure beneath the universe's swirling patterns. Its gravity is gentle and steady, guiding stars in orbits they have followed for billions of years. If you imagine the night sky as a vast glowing city, dark matter is the foundation beneath the streets, the hidden stonework that supports every tower. It does not call attention to itself. It does not illuminate or shine. It simply holds the universe together with a soft and constant hand. And so, as you picture the galaxy spinning slowly in the dark, you can think of dark matter as the invisible frame beneath a lantern shade, necessary for the lantern to hold its shape, but never seen directly. It is one of the universe's great quiet gifts, an unseen architecture that cradles everything we know and everything we are. If you've ever watched steam rise from a cup of tea, you might have noticed the way it spreads upward and outward, drifting gently into the room. It expands without hurry, without sound, without forceful motion, just a slow upward bloom. There is something similar, softly similar, happening to the universe itself. Not in the way steam warms the air, but in the way space stretches, quietly, gradually, relentlessly. And behind this expansion, guiding it like a steady breath, is one of the most mysterious forces we've ever discovered, something we call dark energy. The name might sound dramatic, but the truth of it is far subtler. Dark energy is not a storm, or a glow, or a pulse. It isn't a wind pushing galaxies apart. It doesn't swirl or flow. Instead, it is something woven into the fabric of space itself. Every inch of space, no matter how empty or quiet, carries a tiny push, a faint pressure that encourages expansion. The larger the universe grows, the more of this gentle pressure there is, and the faster the expansion becomes. You can imagine it like the slow stretching of fabric. At first, the cloth moves only slightly, but as it stretches, it creates more room for further stretching. And the more room it creates, the more places there are for that quiet pulling to continue. It is a self-sustaining motion, soft but persistent. For a long time, scientists believed the universe's expansion was slowing down. That would make sense. Gravity, after all, pulls things together. The galaxies, the stars, the vast clusters floating in the night, they all tug on one another gently across cosmic distances. It seemed natural that over billions of years this pull would gradually slow the expansion, like a runner growing tired. But then came a surprising discovery. By observing distant supernovae, exploding stars that shine with a known brightness, astronomers could measure how fast the universe was stretching in the past. And what they found was unexpected. Instead of slowing down, the expansion was speeding up. Slowly, yes, but undeniably accelerating. It was as if the universe had taken a deeper breath and begun to stretch more quickly, not less. This was the first sign of dark energy, a curious, quiet force hidden in the vast spaces between galaxies. Think of the universe as a kind of cosmic quilt, expanding at the edges. Dark energy is like a soft tension woven into the threads. It doesn't pull objects apart directly. Instead, it gently stretches the space between them. A galaxy does not feel pushed away from another galaxy. Rather, the space connecting them grows, like new fabric forming between two drifting ships. The ships have not moved under their own power. They simply find themselves farther apart because the water beneath them has deepened. Even more mysterious is the fact that this stretching is smooth and uniform. It does not prefer one region over another. It does not twist or distort. It expands space like a rising loaf of bread, lifting every corner evenly. Whether you look near or far inside a galaxy cluster, or at the vast voids between them, the expansion behaves the same everywhere. In the earliest moments after the universe began, there was a period when this expansion happened at an astonishing rate. A moment of almost unimaginable rapid growth known as inflation. You could imagine it as the universe blooming in less than a breath, expanding from smaller than a grain of dust to cosmic size in a fraction of a second. Dark energy is not the same thing as that early inflation, but it may be related in some distant way, like a whisper left behind by a storm long faded. Both push outward, both shape the cosmos, and both invite the same quiet question. Why? There is comfort in knowing that dark energy does not act violently. It does not tear galaxies apart or stretch stars until they break. Gravity, strong in the dense, bright places where matter gathers, holds those structures steady. Dark energy acts mostly in the enormous silent gaps between galaxy clusters in the great empty rooms of the universe. If space were a house, dark energy would be the gentle expanding of its walls, not the rearranging of its furniture. What is dark energy, truly? That remains one of the largest questions in modern science. It could be a property of space itself, a kind of built-in pressure. It could be the collective effect of tiny fluctuations, the soft stirring of the vacuum. It could be something entirely new, something we haven't yet found the right language for. Whatever it is, it makes up most of the universe. Far more than the stars, the planets, the dust, and even the dark matter. It is strangely soothing to realize that the universe is held together by invisible forces and shaped by silent ones. Gravity binds galaxies, dark matter frames them, and dark energy sets the rhythm of their drifting. We see the stars, but what shapes them is mostly unseen. When you look up on a clear night, the stars seem steady. The constellations look unchanged from year to year, but across the depths of space, everything is slowly moving apart, like glowing lanterns drifting on a dark lake. The distances between galaxies widen, not because they push away from one another, but because the lake itself is expanding. There is a quiet poetry in this. It means that the universe is not static. It breathes, it grows. Its very structure is dynamic, not just in the bright places where stars ignite, but in the dark, open spaces where nothing seems to happen at all. As you rest with this thought, you might imagine the universe stretching gently, the way you might stretch in the morning after waking. It does not strain. It simply expands, guided by a force you will never see directly, a force that does its work silently, yet profoundly. A force that shapes the future of galaxies, the fate of stars, and the ultimate story of everything that exists. If you've ever watched a pebble fall into a still pond, you know the quiet poetry of ripples. They begin at the point of impact, small and soft, then drift outward in widening circles, carrying the memory of that moment across the surface. Even when the pebble is gone, the water continues to speak of where it fell. Gravity, the familiar force that holds your feet to the ground and guides planets along their paths, can create ripples too. Not in water, but in the fabric of space itself. And though these ripples are unimaginably faint, they carry stories from the most dramatic events in the universe. These are gravitational waves. They travel through space the way a soft tremor passes through a sheet of fabric, stretching and squeezing the very structure of reality as they go. Unlike light, they are not blocked by dust or gas. They do not dim with distance in the same familiar way. They pass through everything effortlessly. Stars, planets, your body, the quiet walls around you, leaving behind distortions so tiny they slip beneath all your senses. You cannot feel them, you cannot see them, and yet they move through you all the time, carrying whispers of ancient collisions and cosmic dances that unfolded billions of years ago. Imagine two black holes circling one another in the deep silence of space, their orbits slowly spiraling inward. With each loop, the space around them stretches and contracts, pushing out waves. As the black holes draw closer and spin faster, the waves grow stronger, like the rising swell of distant thunder. And then, when they finally merge, they send out a powerful ripple, a final deep note in a cosmic symphony. That ripple travels across the universe for ages until eventually it glides past Earth, faint and delicate like a breath of wind across a spider's web. For most of human history, these waves passed unnoticed. The Earth has been embraced by countless gravitational whispers, but our senses were never made to detect them. Even our earliest telescopes, our most careful instruments, looked for light, not for the motion of space itself. To detect these faint stretches and squeezes, we would need something as sensitive as a dream catching the fall of a single feather. And somehow, astonishingly, we built such a tool. The first observatories able to listen for gravitational waves work by sending beams of light down long tunnels, measuring how space stretches and shrinks by amounts so tiny they defy imagination. The change is smaller than a fraction of the width of an atom, smaller even than the shift of a shadow at midnight. And yet, with enough patience, enough stillness, enough precision, the detectors can hear the soft arrival of a wave. When the first detection happened, it was like hearing the universe clear its throat for the very first time. The signal was a rising tone, a gentle chirp lasting only a moment. But in that moment was the story of two black holes dancing together more than 1 billion years ago. Their merging sent out a wave that travelled across time and space before reaching us, unchanged, still holding the imprint of its origin. It was a reminder that even the most distant events leave echoes, and that space itself remembers. To imagine what a gravitational wave feels like, picture yourself lying in a quiet room as a train passes far, far in the distance. The floor beneath you trembles so faintly that you barely notice it. That long, deep shiver is similar to the way a gravitational wave passes through Earth. The stretching and contracting is so gentle that everything moves together and nothing feels out of place. These waves do more than confirm predictions. They reveal hidden chapters of the universe's history. Because they travel through everything, they can carry stories from places no light can escape. Colliding black holes, neutron stars spiraling together, the trembling of space-time moments after the universe began. With each detection, we learn a little more about how existence moves beneath the surface. There is something comforting about knowing that the universe is not silent, even if it seems that way from afar. It hums, it shivers, it sings in ripples too soft to hear, without instruments built with extraordinary patience. And just as a stethoscope lets a doctor listen to the quiet beating of a heart, gravitational wave detectors allow us to listen for the pulse of the cosmos. The most beautiful part is how gentle this cosmic whisper is, even when the events that create the waves are violent collisions, explosions, the collapse of stars. The waves themselves arrive like the softest of touches. They never disturb your breath or shift the blanket around your body. They move through you almost tenderly, a reminder that the universe communicates not only through the bright dramatic light of stars or the vast motion of galaxies, but also through the faint trembling of space itself. As scientists continue listening, new stories will emerge. Perhaps waves from the birth of the first stars, perhaps signals from unknown objects dancing in distant galaxies, perhaps echoes from the earliest fraction of a moment after the universe came into being. Each wave will arrive quietly, slipping through space like a message in a bottle drifting across a cosmic sea. For now, as you rest, you can imagine these waves passing around and through you, subtle, ancient ripples that stretch the world imperceptibly, carrying tales from regions of space you will never see. They remind us that everything is connected, not only through light and gravity, but through the gentle trembling of reality itself. And somewhere out in the universe, another wave has already begun its journey toward us, moving slowly and steadily across the dark, bringing with it a story we have not yet heard. If you imagine space as an endless silent stage on which stars drift and galaxies turn, you might picture it as something still, an emptiness waiting to be filled. But space is nothing like a blank page. It bends, it curves, it stretches, it folds. It is flexible in a way that defies intuition, soft enough to be shaped by the presence of matter, but firm enough to guide the motion of everything within it. Every step you take is laid across this quiet curvature, even if you never feel it directly. A gentle way to picture it is to imagine a vast fabric stretched across a room. If you place a small pebble on that fabric, it creates the tiniest dip, barely noticeable. Now place a larger stone, and the dip deepens. A heavy ball, heavier still, drags the fabric into a deep, smooth well. This is the way mass shapes space. A planet creates a slight indentation. A star makes a deeper one. A black hole pulls the fabric down in a steep, almost vertical drop, and the paths that objects follow, whether a falling apple or a circling moon, are guided by these curves, the same way marbles roll along the folds of cloth. This idea might feel abstract, but its effects are gently familiar. When you drop something and watch it fall, you're witnessing the shape of space-guiding motion. It is not that the object wants to fall, but that the landscape it moves through is curved in that direction. When the Moon orbits Earth, it does not constantly adjust its course. Instead, it follows the natural arc of space around our planet, gliding along the contours like a leaf floating in a slow-moving whirlpool. Time is woven into this fabric as well. Where space curves deeply, time flows differently. High above the surface of Earth, where the pull of gravity is weaker, time passes a bit faster. The difference is tiny, far too small for human senses to detect, but it is real. It's as though time is a soft river that flows at slightly different speeds depending on how steeply the landscape dips. In deep valleys carved by massive objects, the river slows. On wide plateaus of gentle curvature, it runs more quickly. Even the devices we rely on every day must account for this. Satellites orbiting above Earth carry clocks that run a little faster than clocks on the ground. Without correcting for this difference, the navigation systems we use, those quiet companions guiding us down roads and across oceans, would drift off course. Our technology has to acknowledge that space and time are not rigid or absolute. They're shaped continuously by the mass around them. The most elegant aspect of this idea is how it reframes gravity. Instead of a force pulling objects downward, gravity becomes the natural motion of things following the curves of space-time. It is a shift from imagining invisible ropes tugging on apples and planets to imagining them simply moving along the most comfortable path offered to them. The apple falls because the space around Earth bends gently inward. The Earth orbits the Sun because the Sun creates a great smooth basin in space that guides Earth's path. You might imagine an object travelling through this curved fabric as a person walking blindfolded across a gently sloping field. They do not feel compelled or pushed, they simply follow the contours beneath their feet. Gravity works the same way. It is the quiet structure beneath motion, not a force acting from outside. These curves are not static. The fabric of space-time changes whenever matter moves. When a star drifts across the sky, the space around it ripples and reshapes. When a planet circles its sun, it does so in a landscape that subtly shifts beneath it. Even your movement changes the curvature around you, though the change is unimaginably small. Space-time responds to everything. Every grain of dust, every ray of light, every drifting molecule, reshaping itself continuously, effortlessly. One of the most striking examples lies near extremely massive objects. Close to a black hole, where the curvature of space becomes steep and intense, time slows dramatically. If you could hover safely near its edge, something no ordinary matter could do, your seconds would stretch relative to those of someone far from such a gravitational well. This stretching is not caused by a machine or a force, but by the fabric of space-time itself, pulled into such a deep fold that time's flow becomes languid. And yet, despite these dramatic ideas, you live your entire life without noticing the curves beneath you. Space-time feels flat and uniform because the variations in curvature near Earth are gentle. It is like lying on a vast hillside so broad and smooth that you never notice the slope. Only when you zoom out, far beyond the scale of ordinary life, do the curves become apparent. It can be soothing to think of space-time not as an empty void, but as a soft, responsive medium. It holds the universe like a cradle, shaping the paths of stars with the same ease that a river shapes its banks. It connects distant regions through gentle flows and subtle curves, and it listens to every movement, adjusting its shape with extraordinary sensitivity. In this view, you're not merely moving through space, you're gliding along the contours of a vast invisible landscape that supports your every motion. The Earth's orbit is a slow dance guided by the Sun's gravitational well. The rising and setting of the Moon follow the soft outline carved into space by Earth's mass. Even the simple act of standing still is an interaction with this unseen fabric. Your body presses gently downward as space curves to meet you. There is a quiet comfort in knowing that space-time holds everything in place. It does not rush. It does not falter. It stretches and bends with the rhythm of the cosmos, shaping the universe with a patience too immense to measure. As you rest with this image, you can imagine the world beneath you not as a solid floor, but as a gentle slope in an invisible landscape, a landscape that guides planets, stars, and even the flow of time. There is no force pulling you down, only the subtle guidance of curves beneath your feet, carrying you through the night with the same softness that shapes the motion of galaxies. If you have ever stood before a glass window at night, you may have noticed the way reflections blend with what lies beyond. The lights inside the room hover on the surface of the glass, while the faint shapes of the outside world linger behind it. Two realities, one right in front of you, one further away, layered quietly over each other. It is a simple moment, but it hints at something much deeper, the possibility that what we experience as a three-dimensional world may be tied to information stored in places we cannot see, woven into boundaries far beyond our reach. This idea, gentle in its tone yet profound in its consequences, is at the heart of what scientists call the holographic principle. It does not suggest that the world is an illusion or that your life is a trick of light. Instead, it proposes something subtler, that the deepest description of the universe may not reside in the space we move through, but on distant surfaces that act like cosmic ledgers, quietly storing the information that gives rise to everything inside. To picture this in a soft, approachable way, imagine holding a familiar hologram, a small, shimmering card that changes its image as you tilt it. The card itself is flat, only two-dimensional, yet the image you see appears three-dimensional. Its depth, its curves, the sense of space, it all arises from patterns etched into the surface. Nothing about the card is actually deep, and yet it creates the appearance of depth through the careful arrangement of information. Now stretch that image outward, not to a tabletop or a room, but to the universe itself. Imagine that the vast space you move through, the space that seems so open and full of depth, may be a kind of projection of information encoded on the edges of the cosmos. Those edges might not be walls or boundaries as you normally imagine them. They could be distant horizons, invisible surfaces where gravity and light leave their marks. The sensation of living inside three dimensions, walking forward, reaching upward, watching clouds drift, is entirely real. But the fundamental blueprint, the deepest version of the universe's story, could be written in one fewer dimension than you experience. This idea emerged from studying black holes, objects so dense and so mysterious that they reshape space in a way that defies familiar language. A black hole has a boundary known as the event horizon, a place where gravity becomes so strong that nothing, not even light, can return once it has crossed. For many years, physicists tried to understand what happens to information that falls into a black hole. Does it vanish forever, erased from existence, or does it survive in some subtle form? The surprising insight was that the information seems to cling to the horizon itself, like frost on a cold window pane. It doesn't gather at the centre, as one might imagine, but spreads thinly across the surface area of the boundary. This led to a gentle but powerful shift in perspective. Perhaps the fundamental description of a region of space is not found inside it, but on its surface. Just as the instructions for a hologram exist on its flat card, the deepest instructions for a volume of space may live on the surface that encloses it. From this grew the broader thought that perhaps the whole universe follows a similar rule, that what we experience as a three-dimensional world may be shaped by information arranged on a kind of cosmic horizon beyond what any telescope can see. This horizon is not a physical wall, but a distant boundary defined by how far light has travelled since the universe began. Imagine a sphere surrounding you, unimaginably large, marking the furthest reach of light over billions of years. That sphere is one version of this horizon, and some theories suggest that the information describing everything inside is encoded upon it. A soft way to imagine this is to think of the universe as a vast book. You live inside its pages surrounded by scenes and details, but the deep structure of the story, the author's instructions, could exist on the book's cover, holding the blueprint for all that unfolds inside. You experience the world from within, but its foundations may be stored at the edges. This does not make your surroundings less real. The holographic principle does not flatten the universe or erase its depth. Instead, it suggests that depth may emerge from relationships encoded elsewhere. Space, in this view, is a woven tapestry of connections, its shape arising from how information is arranged on distant boundaries. Even more soothing is how this idea ties into entanglement, the quantum connection that links particles across distance. If you imagine space as a fabric woven from these connections, threads linking one region to another, then the entire geometry of space may arise from patterns of entanglement. Where the patterns are rich and dense, space thickens and curves. Where the patterns loosen, space becomes thin. The universe becomes less like a stage and more like a delicate web, whose shape emerges from invisible threads. These concepts can feel abstract, but they carry a gentle beauty. They suggest that reality is relational, built not from rigid blocks or empty voids, but from the way information and connections intertwine. Even the solidity of your room, the quiet comfort of your bed, the distance between your breath and the ceiling above, all of it may arise from the harmony of these deeper patterns. As you imagine this, you might picture the universe not as a cold, mechanical structure, but as a softly organised library of information, its deepest laws written across cosmic boundaries. You're not outside this script. You're part of it. A pattern within the pattern, a ripple within the larger weave. When you look up at the night sky, the stars seem scattered across a great dome. The space between you and them feels deep and open. The holographic idea whispers something subtle, that this depth may be a kind of gentle illusion created from a faraway page. Not a deception, but a revelation that the universe may be far more interconnected than we ever guessed, its interior shaped by stories written at its edges. If you close your eyes and imagine two lamps in a dark room, you might picture them standing apart, each casting its own small pool of light. But now imagine something stranger. Instead of two separate flames, both lamps share one and the same flame, a single glow somehow living in both places at once. If one lamp flickers, the other responds, even though no visible wire or cord connects them. This is a gentle way to picture one of the most mysterious features of the quantum world, entanglement. In the quiet language of physics, entanglement is a relationship between particles so deep that they can no longer be described independently. Whatever happens to one is tied in some subtle way to what happens to the other, no matter how far apart they drift. You cannot think of them as two separate objects, only as a shared state. Like our two lamps with one flame, they are distinct and yet not entirely separate. Now stretch this image a little further. Imagine that instead of just two lamps, there are many small points of light scattered through a dark, vast space. Some pairs share a flame. Some groups share a pattern of flickers. Some glow together in quiet harmony. The connections aren't drawn with lines or cords, but they are there all the same, weaving an invisible network through the dark. Some physicists have begun to imagine that these invisible connections might be more than just curious quantum relationships. They might be the very threads that weave space itself. In this view, what we call space is not a pre-existing stage on which things appear, but the result of how strongly different parts of the universe are entangled with one another. Where connections are dense and rich, space feels close and well stitched. Where connections thin out, space stretches and becomes distant. Geometry, the shape and structure of space, arises from relationships, not from rigid coordinates. To make this feel more tangible, you can picture a web made of countless glowing fireflies. Each firefly is a point where something can exist, a node of possibility. Between them, faint lines form where they share light, gentle strings of entanglement. In some regions, the fireflies are heavily interconnected, forming tight clusters where everything is closely linked. In others, the connections are sparse, with only a few threads bridging wide gaps. If you looked at this web from far away, you would see not individual insects, but a woven fabric of light. That fabric is a metaphor for space itself, built from the pattern of connections. Some theories take this idea further and suggest that certain kinds of quantum connections could even resemble tunnels, tiny bridges threading between distant regions. In more technical language, these are called wormholes. Imagine wrinkles in the fabric of space that link two locations as if folding the universe in on itself. The bold proposal, made by a few thinkers, is that these wormholes and entanglement could be different faces of the same underlying phenomenon. In our lamp metaphor, that would be like saying, the shared flame between two lamps and a hidden passageway between them are not separate mysteries, but two ways of talking about a single, deeper connection. It's as though every entangled pair creates a microscopic tunnel in the fabric of reality, a secret corridor of correlation rather than a visible bridge you could travel through. Whether or not this image turns out to be literally true, it offers a soft, intuitive way to think about how linked the universe might be at its foundations. Another way to picture this underlying structure is through what some physicists call spin networks. Instead of a smooth, continuous space, imagine a collection of points connected by lines, like a constellation map or a delicate beading of stars on invisible threads. Each point holds a tiny amount of space, and each connection carries a quantum of relationship. How these pieces of reality fit together. The network shimmers and shifts, constantly updating itself as the universe evolves. In your mind, you can let these points become small fireflies, suspended in darkness, each linked to others by threads of faint light. Where many threads meet, the network thickens, forming something resembling a surface or a region. Where the connections are thin, it feels more like a gap or a boundary. What we experience as distance, curvature, and even direction might arise from this deep, underlying web. It is as if the world you move through is the smooth outer fabric of a garment, while beneath the surface lies an intricate stitching of quantum threads. In this picture, space-time, the familiar fabric of space and time described by curved geometry, does not sit at the bottom of reality. It is more like a pattern that appears when you step back far enough from the network of fireflies and threads. At a distance, the points blur together, and the lines merge into what looks like a continuous surface. The smoothness is an illusion born from scale, the way a cloth looks unbroken even though it is made of individual threads. This perspective can feel quietly profound. It suggests that reality is relational in its deeper sense, not built from solid blocks but from connections and shared states. Where something becomes less important than how it is linked to everything else. Location dissolves into relationship. Geometry becomes the language of entanglement. If this sounds abstract, it may help to return to the feeling of lying still beneath a blanket. You sense the surface, smooth, unbroken, soft against your skin. You do not see the individual fibres, the interlocking threads that hold the blanket together. Yet those threads are what give the blanket its strength and warmth. In the same way, you never see the quantum threads that may weave space, the entanglement that might cradle every point in reality. You only feel the result. A world that seems continuous, a space that seems stable, a stage on which events unfold. As you rest with this thought, you might imagine yourself not simply sitting in space, but resting in a vast web of connections, threaded through by countless invisible relationships that define your place in the universe. You're not separate from this web, you're part of its pattern, a node among many, glowing softly in the dark. If you've ever watched the shadows of tree branches dancing on a wall at dusk, you might have noticed something curious. The shapes stretch and shift, forming patterns that look alive, even though the true motion is elsewhere. In the wind rustling the leaves, in the branches gently swaying, what you see is not the thing itself, but a projection of deeper movement. This simple scene offers a quiet doorway into one of the most thought-provoking ideas in modern science and philosophy: the possibility that reality behaves like a vast natural computation, unfolding according to deep rules that operate beneath what we see. It is tempting to think of the simulation hypothesis, the way popular culture sometimes portrays it: humans trapped inside a computer program, reality built from artificial illusions, a hidden architect watching from beyond. But that is not the gentle, contemplative version we'll explore here. Instead, imagine something softer, more organic. The universe as a system that naturally computes itself, not because it is designed by someone, but because the laws of physics guide each moment into the next with quiet precision. To understand this without slipping into images of digital screens or blinking circuits, it can help to think about simple rules in nature that create stunning complexity. Consider a snowflake forming in a cold cloud. The rules governing how water molecules arrange themselves are simple: align this way, turn that way, bond at these angles. Yet from those rules emerges a structure of such delicate detail that no two snowflakes are alike. The snowflake is not designed, it emerges from the rules. Or think of the intricate patterns of a seashell, or the branching forms of a fern. These arise from repeating processes that act like small instructions carried out over and over again. In this way, nature resembles a story that writes itself, line by line, each sentence following from the last. Now take that idea and lift it upward, from snowflakes and ferns to galaxies and particles. Imagine the universe as a vast sheet of instructions, woven into the fabric of space-time, determining how everything evolves. Matter follows certain patterns, energy follows others. Quantum fields evolve according to their own gentle rules. The cosmos does not need to be told what to do. It simply follows the logic built into its foundations. In mathematics and computer science, there is a concept called a cellular automaton. It is a grid where each cell, each tiny square, follows a simple rule depending on the state of its neighbours. Perhaps a cell becomes bright if two neighbours are bright, or fades if it is alone. These rules are not complicated. Yet when you let the grid evolve step by step, astonishing patterns emerge: shapes that move, structures that grow, waves that ripple, all from rules simple enough to write on a postcard. Many researchers have wondered whether the universe might operate in a similar way, not as a program simulation, but as a kind of natural automaton, a system that updates itself in tiny steps according to underlying relationships. If that feels too mechanical, imagine instead a river flowing. Each drop of water interacts with others according to the same basic laws: pressure, motion, temperature, depth. And yet, the river never repeats itself. A leaf drifting along its surface is carried by countless small influences that create a journey both patterned and unpredictable. The river computes its motion naturally, without being programmed, without needing conscious guidance. The universe may act in the same way, a flowing, self-updating system governed by consistent rules. This idea leads to a gentle question. If the universe behaves like a computation, what exactly is being computed? One soothing way to think of it is that reality is computing its own next state. Every moment arises from the last through the laws of physics, like a story unfolding one sentence at a time. The motion of planets, the blooming of flowers, the firing of neurons in your mind, all are part of the same unfolding process. But this does not mean the universe is unreal or synthetic. It only means that the laws of nature are deeply orderly, and that this order gives rise to everything we experience. You're not a character trapped inside a program. You're part of a process that stretches from the smallest vibration of quantum fields to the vast arcs of galaxies spinning in the dark. In this gentle computational view, even the passage of time takes on a new texture. Time becomes the rhythm of the universe updating itself, moment to moment, heartbeat to heartbeat. Each instant builds on the last, carrying forward information like a quiet, continuous melody. The present is the universe reading its own story as it writes it. Of course, there are more speculative versions of the simulation idea, versions that imagine advanced civilizations running universes of their own. But those versions are not necessary for this story, and they lean more toward fiction than gentle scientific curiosity. The version we hold here is softer, more grounded. The universe does not need a programmer. It runs because its rules allow it to run. It unfolds because that is what the laws of nature produce. If you picture the night sky, the stars shining like small lanterns scattered across a dark field, you can imagine the entire scene updating, moment by moment, like a soft, continuous flow of information. Each star follows the rules of its own nuclear fires. Each planet traces its path along the curves of space-time. Each cluster drifts through the quiet influence of dark matter. Nothing needs to supervise these motions. The universe handles them with quiet grace. Everything you see, everything you touch, everything you imagine is part of this vast, self-sustaining process. You're not outside it. You're one of its expressions, a pattern emerging from deeper rules, no different in principle from the blooming of a flower or the swirling of galaxies, though infinitely richer in experience and thought. As you settle into this idea, you may find it comforting rather than unsettling. If the universe behaves like a natural computation, it means that every moment you live is part of a coherent, ongoing story. You are woven into the flow of cause and effect, shaped by laws that reach across the cosmos. And though the universe may be complex, its underlying structure is simple enough to allow beauty, life, and consciousness to arise from it. You're not a product of artificial illusion. You're woven from the same rules that shape stars and rivers, part of the quiet computation of existence that has unfolded for billions of years and continues softly around you. If you sit quietly for a moment, letting your breath soften, letting the room settle around you, you may notice something gentle but astonishing. Behind your thoughts, behind every sensation, behind the drifting images of memory and imagination, there is an awareness watching it all unfold. It doesn't shout or demand attention. It glows softly, like a lantern set deep inside a quiet house. This awareness, your consciousness, is so familiar that you rarely question it. And yet, it is one of the most mysterious features of the universe. Consciousness feels simple from the inside, but when we look more closely, it becomes wonderfully complex. It is not merely the collection of your senses, because you can close your eyes and still be aware. It is not merely your thoughts, because you can observe them come and go, like waves rising and falling. Consciousness sits behind these experiences, receiving them, shaping them, and sometimes even redirecting them. It is both a mirror that reflects the world and a participant that interprets it. Some thinkers describe consciousness as the quiet light inside the skull, a soft illumination that makes it possible for you to experience the world at all. Without that inner light, colours would be meaningless, sounds would be vibrations with no significance, and the world would move past unnoticed. Consciousness gives texture to reality. It turns raw sensation into lived experience. But is this awareness merely witnessing the world? or does it play a deeper role in shaping it? For decades, scientists have explored the boundaries of perception, using experiments that examine how the mind forms a model of the world. What we know is that consciousness does not display reality as it truly is. Instead, it offers a simplified version, one optimized for clarity and survival. It selects, filters, compresses, and presents. You do not see the world, you see your brain's interpretation of it. This interpretation is elegant and efficient. Your mind gathers light from your surroundings, translates it into patterns, and then builds a scene that you can understand. It hears sounds, breaks them into meaningful shapes, and tells you whether you're hearing footsteps or wind brushing past a window. It feels pressure, temperature, texture, and turns them into comfort, caution, or curiosity. Consciousness rests atop this complex machinery like a peaceful observer receiving the world second-hand. And yet, there are moments when it seems to influence the world beneath it. When you decide to reach for a glass of water, your intention, something not visible, not tangible, creates ripples in your brain. Neurons shift into patterns. Signals cascade through your muscles. In a sense, a thought becomes action. A quiet intention transforms into movement. Awareness participates. Some theories explore consciousness not as a separate entity floating above the physical world, but as something woven deeply into it. One of these theories, often described with gentle imagery, imagines consciousness as the shape of information within the brain. In this view, consciousness is not a spark or a command center. It is the form created when information becomes sufficiently rich, interconnected, and organized. Like a tapestry woven from many threads, consciousness emerges when the patterns become complex enough to sustain an inner light. You can picture it as a field of tiny lamps, neurons, glowing in intricate patterns. When the pattern is simple, the glow is dim, like a few scattered lights at dusk. But when the lamps connect in vast looping networks, their combined glow forms something far brighter. The quiet presence you feel as your own awareness. This perspective also suggests that consciousness is not an object we possess, but a process we participate in. It shifts as we learn, rests when we sleep, and glimmers with new connections as our experiences grow. The mind is not a static mirror. It is a living, changing landscape. And yet, the most intriguing question remains. Does consciousness shape reality, or does it merely witness it? In the realm of quantum physics, observers affect outcomes, not through intention or thought, but through the act of measurement itself. This does not mean consciousness molds the universe the way a painter molds a canvas. Instead, it hints at a delicate boundary where information, observation, and reality intertwine. The universe responds not to human intention, but to the very moment something becomes knowable. Reality crystallizes from possibility into form when it interacts with the world in a way that can, in principle, be observed. This interplay invites a soft, contemplative view. Perhaps consciousness is not the architect of reality, but a participant in its unfolding, a partner rather than a creator, a witness whose presence adds a dimension of meaning to the universe's ongoing story. In your daily life, this relationship shows itself in quieter ways. Your awareness influences how you interpret the world. Your thoughts shape your reactions. Your memories color your choices. Your attention steers the flow of your experience. You're both an observer and a participant in the life unfolding around you, and yet consciousness remains gentle. It does not need to solve the universe to feel wonder. It does not need to command the stars to appreciate them. It does not need to shape reality to find a sense of belonging within it. Awareness itself, the quiet glow behind your thoughts, is already one of the universe's rarest and most remarkable phenomena. As you rest with this idea, you might imagine consciousness as a small flame sheltered within a lantern, flickering softly but steadily. It illuminates just enough of the world for you to walk through it without fear. It warms your inner experience. It glows with the quiet truth that you are here, alive, aware, a participant in a vast and mysterious universe. If you've ever watched dust swirl in a beam of sunlight, you may have noticed how delicate the movement is, how a small breath or the slightest tremor can change the pattern completely. The quantum world is even more sensitive than that. Down in the smallest scales of nature, where particles move like whispers and possibilities drift like morning mist, even the act of observing becomes part of the story. Not because consciousness bends reality through sheer will, but because measurement, any interaction that leaves a trace, nudges the system gently, like a fingertip brushing the surface of a still pond. In classical life, observing seems passive. You look at a star, and the star does not mind. You listen to a river, and the river's flow does not change. But in the quantum world, observation is an interaction. You cannot look at something without touching it in some small way, because looking requires light, and light carries energy. To observe is to exchange information, and in that exchange the delicate quantum possibilities begin to settle. One of the simplest ways to feel this idea is through the story of the double-slit experiment, a tale told so often that it risks sounding like a legend, but whose heart still offers quiet wonder. Imagine a screen with two narrow openings, like two windows standing side by side. If you send tiny particles, little points of light, toward the windows one at a time, you might expect them to pass through one or the other, landing behind in two neat groups. But the particles do something unexpected. They interfere with themselves, as though each particle goes through both windows at once, leaving behind a pattern not of two groups, but of many alternating bright and dark bands, like ripples overlapping on the surface of water. It is as if the particle explores many paths, many possibilities, before settling somewhere on the screen. But then something even stranger happens. If you place a detector at the windows to watch which path the particle takes, the rippling pattern disappears. Instead, the particle behaves as though it chose a single path. Simply by measuring, by allowing the information about its path to exist, you nudge the system into selecting a definite outcome. This does not mean the particle knows it is being watched. It means that the act of measurement changes the configuration of the system. The measurement is like a soft tap that breaks the delicate superposition of possibilities, leaving behind only one. In everyday life, these changes are so small, so subtle, and so overshadowed by countless interactions that we never notice. But at the quantum scale, they shape the behavior of matter. This process is often described using the gentle term decoherence. When a quantum system is isolated, its possibilities remain rich, like a cloud of soft potential. But when it interacts with the environment, light, air molecules, or any detector, the cloud begins to settle. Decoherence is like watching a fog slowly collapse into a single droplet, or a blurry painting coming into focus. It is not a collapse born from consciousness or intention. It is simply the universe choosing one story from many, guided by the interactions that become possible as systems meet. An easy way to imagine decoherence is to picture a spinning coin. While it spins, both sides remain in play. The coin is neither heads nor tails, it is a blur of possibilities. But once it hits the table, the spin slows, and the coin settles. It becomes one thing or the other. The settling is not magic. It is a natural response to interacting with the world. Quantum systems behave similarly, though their spin is not physical motion but a haze of possible outcomes. In everyday life, everything around you has already decohered. The objects in your room do not hover between being here and not being here. The blanket covering you does not shimmer between multiple states. At large scales, the interactions are too frequent, too rapid, too overwhelming to maintain quantum delicacy. The world stays stable and familiar because decoherence happens constantly, smoothing the universe into a coherent story. It is soothing to understand that the observer effect is not about human awareness bending the universe, but about the gentle fact that interactions change systems. When you flip on a light in a dark room, the light touches everything, even the dust motes. And so it is with quantum measurement. The act of gathering information introduces a small touch, and that touch changes what is observed. Yet the idea still holds a quiet beauty. It suggests that reality is not a rigid, unchanging stage, but a soft, flexible unfolding. Possibilities settle into facts not abruptly, but through the subtle meeting of systems. The universe behaves like a story written in pencil, first sketched lightly, then traced with firmer lines as interactions grow. Even in your own life, you can feel echoes of this principle. When someone asks you a question, your answer takes shape in the moment. When you reflect on a memory, it shifts slightly, shaped by your current mood. When you look closely at an idea, it crystallizes. Awareness does not dictate reality, but the act of paying attention shapes the way experiences take form. In this way, the quantum world mirrors familiar aspects of the human world. It reminds us that interactions matter, that attention matters, that even the gentlest touch can change the story unfolding before us. If you imagine yourself lying in a quiet room as the world dims, you can think of the universe not as something distant and mechanical, but as something soft and participatory, settling possibilities into patterns, shaping outcomes with each interaction, shaping even the light that brushes your eyes as you drift into rest. When you think back on your life, you might remember small moments that felt strangely connected. Perhaps you were thinking of someone just before they called. Perhaps you stumbled upon a phrase at the exact moment you needed to hear it. Or maybe a pattern appeared in the turning of events that made you pause and wonder whether something deeper was happening beneath the surface. These moments, often called synchronicities, can feel like gentle taps on the shoulder, as though reality is weaving threads together in a way that speaks directly to you. Humans are natural pattern seekers. From the first days of our species, noticing patterns meant survival. The shifting of seasons, the movement of animals, the quiet warnings in the wind. Our minds learn to detect meaning in sequences, to predict, to connect, to search for order in the world. This ability remains at the heart of our experience today. It is why you see shapes in clouds, why melodies linger, why stories feel satisfying when events come full circle. Pattern seeking is not a flaw. It is one of the mind's most beautiful skills. But sometimes, the patterns we see are not woven by the universe. They are woven by the architecture of our own thoughts. The brain is constantly stitching impressions together, trying to make sense of countless details. Even randomness, when filtered through this quiet cognitive loom, can appear meaningful. Two events that mean nothing to one person might feel deeply connected to another, not because the universe tied them together, but because the mind uses them to form a narrative. This does not make these experiences trivial. There is beauty in the way the mind looks for coherence, in the way it turns scattered moments into something that feels whole. You can imagine your brain as an artist sitting before a canvas, turning irregular marks into a picture. The marks themselves may be random, but the image that emerges can still be profound. To understand this more gently, think of how birds flock. Each bird follows a few simple rules. Keep close to your neighbours, match their direction, avoid collisions. From those rules, breathtaking patterns emerge, waves of motion that ripple through the sky, shapes that form and dissolve effortlessly. No bird sees the whole pattern. Each one simply follows its local cues. But from these local interactions comes something global, something astonishing. Synchronicities can feel similar, local cues forming a larger experience that feels meaningful even if no central force is directing it. The natural world is full of emergent patterns, fractals in the branching of trees, spirals in shells, webs in cracks of drying earth. These forms arise without intention, guided only by quiet rules of growth and tension. Your mind, too, creates patterns from the interactions of countless neurons, memories, and impressions. When you notice a coincidence, you're seeing an emergent shape in your inner world, a moment when the brain's quiet architecture brings separate threads together. Yet there is another side to this story, one that requires its own gentle space. Meaning is not always in the events themselves. It is often in the way we receive them. Two people might experience the same coincidence, but only one finds meaning in it. The meaning belongs to the observer. It arises from memories, emotions, hopes, and the subtle lenses through which consciousness interprets the world. In this way, synchronicity becomes a reflection, a soft echo of your inner state. Imagine walking through a forest as sunlight filters through the leaves. You might notice how the golden patches on the ground seem to form a path, guiding you gently forward. But the path is not placed there intentionally. It is created by your perspective, your angle to the sun, your position among the trees, the movement of clouds overhead. The pattern emerges as you walk. Synchronicities work in much the same way. They are patterns created from the meeting of inner and outer worlds. Still, these moments can feel deeply comforting. They remind us that life is not entirely random, that there is room for resonance, harmony, and poetic coincidence. Even if these connections arise from the architecture of the mind rather than the hands of the universe, they are no less beautiful. They show that your consciousness is not a passive observer. It is an active creator of meaning, weaving significance into the world around you. There are times, of course, when patterns in life are more than coincidences. Chaotic systems, the weather, ecosystems, economies, often produce repeating motifs or recognizable cycles without any guiding intention. These patterns emerge simply because systems governed by many interacting parts tend to produce regularity from time to time. In the same way, your thoughts, habits, and emotions interact in ways that create familiar loops and rhythms. When you notice echoes between your inner world and the outer world, you may be noticing these natural rhythms. As you rest with this idea, you might think of your mind as a quiet garden. Some seeds fall by chance, others by intention. Some flowers grow because conditions are right, others because you took a moment to water them. The patterns that emerge, the synchronies, the coincidences, the gentle alignments, are part of the garden's natural unfolding. They are neither random nor orchestrated from above. They simply reflect the interplay of countless small influences, and perhaps that is what makes these moments so comforting. They remind you that meaning does not always need to come from cosmic design. It can arise softly from within, born of the way your mind listens to the world. You're a participant in meaning-making, not a passive receiver. The world offers its details. The mind weaves them into patterns. Between the two lies the quiet experience of synchronicity, the feeling that life, even in its randomness, can sometimes speak in a whisper that feels personal and warm. If you were to peel back the world like the layers of an onion, softly, slowly, gently, you would discover that reality is not one thing, but many levels woven together. The surface feels simple, the warmth of a blanket, the quiet glow of a lamp, the firmness of the ground beneath your feet. But these familiar sensations sit atop a stack of deeper layers: molecular, atomic, quantum, geometric, and informational layers, each one shaping the next, like a series of hidden rooms beneath a house you thought you knew. You live your daily life in the sensory layer. This is the world of colour, sound, touch, smell, and taste. The world as your eyes and ears and skin translate it. It is not the full picture, but it is a comforting one. Your senses simplify the universe into something manageable. The billions of vibrations, waves, particles, and fields beneath them are too intricate to perceive directly, so consciousness chooses clarity over completeness. In this layer, a cup is a cup, a breath is a breath, and the sky is simply blue. Just beneath this lies the molecular layer, where familiar objects dissolve into clusters of atoms bonded in elegant arrangements. The wooden table becomes a lattice of carbon rings, the air becomes drifting groups of oxygen and nitrogen, and your own body becomes a gentle choreography of water molecules, proteins, and sugars. This layer is quiet and orderly, governed by rules far more specific than the sensory world, but still warm, still graspable, like the pattern of lace beneath a sheet of fabric. And then, one floor deeper, the atomic world opens. Here, the solidity of your surroundings disappears completely. Space becomes mostly emptiness. The table, the air, your body, everything becomes vast caverns with tiny points of charge fluttering within. The nucleus is a small lantern glowing in the centre of an enormous cathedral of empty space, while the electrons dance in blurred orbits, like fireflies moving so quickly their paths become soft clouds. This layer feels less like a world and more like a dream, one where the familiar dissolves into shimmering possibilities. Under that rests the quantum layer, a place where the world behaves unlike anything we experience directly. Objects can be waves or particles or something in between. Probabilities replace certainties. Entanglement links distant points as if they are side by side. Events remain undecided until interactions settle them, the way a spinning coin is neither heads nor tails until it touches the ground. In this layer, reality becomes a fluid tapestry of potential, shimmering softly beneath the world we know. Beneath even this lies the geometric layer, the domain of space-time, where distances and directions emerge from deep patterns of curvature. Here, matter is not a separate substance, but a sculptor that bends the very stage it sits upon. Time flows at different speeds, depending on how deeply space is curved. Gravity becomes the shape of paths, not a force pulling downward. This layer is structured, elegant, and quietly mathematical, even though it feels soft and natural from our everyday perspective. And finally, under it all, there may be an informational layer, a foundation where reality is not built from particles or fields, but from relationships and patterns of information. In this layer, space arises from entanglement, time arises from change, and matter arises from the structure of data woven into the universe. It is the deepest room beneath the house of reality, a place where everything becomes interconnected threads rather than separate things. When you understand that reality is layered in this way, something gentle shifts inside you. The world no longer feels like a collection of isolated objects, but like a stacked system of patterns flowing into one another. You're not simply a body in space. You're a pattern built from countless smaller patterns, a living structure that spans all these layers at once. Your thoughts depend on the firing of neurons, which depend on molecules, which depend on atoms, which depend on quantum fields, all resting on the curvature of space-time, all grounded in information. You're a bridge between the sensory world and the deepest foundations of the cosmos, a point where many levels converge. You live on the surface, but your existence reaches all the way down. This doesn't make everyday life less real. If anything, it makes it richer. When you touch a cup, you are connecting with a structure shaped by invisible forces. When you breathe, you're participating in molecular choreography as old as the Earth. When you think, you're engaging patterns built from the geometry of reality itself. Each moment of your daily life is a quiet conversation between layers you never see, but that hold you, guide you, and sustain you. There is also comfort in knowing that these layers interact so gracefully. The sensory layer protects you from the overwhelming complexity beneath it. The molecular layer provides stability, the atomic layer provides structure, the quantum layer provides possibility, the geometric layer provides order, and the informational layer ties everything together with quiet coherence. Humans live on the surface of this layered universe, but we dream of the depths. We imagine atoms and galaxies, quantum connections and distant worlds. Our curiosity reaches downward and outward, always searching for the next hidden room in the house of existence. And with each discovery we gain not only knowledge, but perspective, a reminder that the world is far stranger and more beautiful than it appears through the narrow window of the senses. As you rest with this understanding, you might imagine these layers as soft, translucent sheets stacked beneath one another. Light filters through them, illuminating each one differently, revealing more detail the deeper you look, and you, resting on the surface, are connected to each layer, shaped by each one, part of the quiet architecture of the cosmos from top to bottom. When you look up at the night sky, the stars seem steady, like tiny lanterns pinned against a dark curtain. They appear eternal, unchanging, softly glowing in their familiar patterns. But what we can see with our eyes is only a thin slice of the universe, a single page in a book whose story stretches far beyond the visible ink. Throughout history, humans have built tools to widen this narrow window. First simple lenses, then telescopes, then great observatories that watch the cosmos from mountaintops and orbital paths. Each generation of instruments has revealed something new, something hidden, something that reshaped our understanding of existence. Now we stand at the edge of another transformation. New technologies, gentle in principle but powerful in reach, are extending our senses into realms we once thought permanently beyond our grasp. These tools are not designed to impress with noise or spectacle. They work quietly, listening to whispers, catching tremors, and revealing phenomena too subtle for ordinary perception. They are expanding our vision, not only outward into distant galaxies, but inward into the unseen layers of reality beneath every moment. The telescopes of the future will be different from the great metal dishes and mirrors we imagine. Some will drift far from Earth, orbiting quietly in deep space, free from the glow and turbulence of our atmosphere, placed in positions where the Sun and Earth align in delicate balance. These observatories will be steady and serene, able to stare at distant galaxies without interruption. With their help, we may see back to the earliest moments after the universe began, not just in faint outlines, but in detail, as though gazing at an old photograph restored with care. Other telescopes will examine the sky not in visible light, but in wavelengths our eyes cannot see. Far infrared, ultraviolet, radio waves, and even the gentle glow of microwaves left over from the universe's beginnings. These instruments will allow us to trace the formation of stars hidden within dust, to watch planets forming in clouds of gas, and to glimpse the structures of galaxies so old their light has travelled for billions of years to reach us. They will reveal the universe not as it appears to the naked eye, but as it truly is, a complex, layered, evolving whole. Alongside these observatories, another family of instruments is emerging: quantum sensors. These devices rely on the delicate behaviour of tiny systems, atoms, electrons, and particles that respond to the slightest changes in their environment. Quantum sensors can detect movements so small they would vanish in the noise of ordinary measurement. They can sense shifts in gravity, electromagnetic fields, and vibrations so faint they would slip past every other detector. Imagine placing a droplet of water on a still pond and watching the ripples spread. Now imagine noticing the tiniest ripple imaginable, a disturbance no larger than the width of a single atom. A quantum sensor can detect that kind of faint motion. By placing arrays of these sensors deep underground or aboard quiet satellites, we can listen for whispers in the structure of space itself. Subtle tremors that might reveal new particles, hidden forces, or even hints of how gravity behaves at the smallest scales. Gravitational wave observatories too are evolving. The detectors we have now are remarkable, capturing the gentle stretching of space-time caused by distant black hole collisions. but the next generation will be even more sensitive. Some will be placed in space, forming triangles millions of kilometers wide. These space-based observatories will listen not just for short-lived chirps, but for the slow, deep notes of massive black holes circling one another for years before finally merging. They will hear waves that pass only a few times per decade, signals so long and low that only a calm, quiet observatory drifting far from Earth can detect them. These future detectors will allow us to trace the cosmic story not only through light, but through vibrations. Space will become an ocean we can listen to, its waves telling stories from epochs long past. A gentle tremor passing through the observatory might be a memory of galaxies colliding, or of dark matter flowing like soft currents, or of exotic objects drifting through the darkness. We will also build instruments capable of probing the nature of dark matter, searching for the faintest interactions between this invisible substance and ordinary matter. Some experiments will place ultra-cold crystals in deep, silent caverns, waiting for the slightest hint of a passing particle. Others will use beams of light as fine as threads of moonlight to detect distortions caused by hidden mass. These devices will not shout their findings. They will whisper them, one carefully measured signal at a time, and then there are the tools that will help us understand the informational side of the universe. Quantum computers, still in their early stages, may one day allow us to simulate tiny slices of space-time, to test how geometry emerges from entanglement, and to explore the deep structure of the cosmos in ways impossible with classical machines. These computers are not just faster versions of what we have, they operate on principles closer to the world they seek to study, using delicate quantum states as both memory and logic. All of these instruments, telescopes, sensors, detectors, computers, extend our reach gently and profoundly. They allow us to touch realities we cannot feel with our hands or see with our eyes. They help us sense the universe not only through light, but through motion, curvature, and information. They invite us to ask deeper questions, to consider possibilities we had never imagined, and to appreciate the quiet richness of a universe that hides most of its story beneath the surface. As you imagine these tools drifting in space, resting underground, or humming softly in laboratories, you can picture them as new senses for humanity. Eyes that can look not only across distance, but across time. Ears that can hear the pulse of galaxies. Fingers that can feel the trembling of space-time. Minds that can explore the foundations of reality through the language of computation. They are instruments for unseen worlds, revealing the universe not as a simple stage, but as a layered, dynamic, deeply connected tapestry. And with each discovery, we come a little closer to understanding our own place within that tapestry. There is a moment, just before you fall asleep, when the edges of the world soften. The thoughts of the day grow lighter, the shapes of the room blur, and everything begins to feel gently distant. As though the mind is loosening its grip on certainty, it is a moment of surrender, quiet, peaceful, and strangely freeing. And in many ways, this moment mirrors our relationship with the universe itself. For all our instruments, discoveries, and theories, we still stand before vast oceans of mystery, not as failures of understanding, but as reminders that the unknown is part of the beauty of existence. Throughout this journey, through fields and forces, through deep space and deep mind, you've seen how much of reality is built from things we cannot see. Invisible scaffolding shapes galaxies. Quiet ripples pass through space-time. Hidden fields vibrate beneath our senses. Layers of existence nest within one another like soft, translucent veils. And consciousness itself glows quietly behind every perception, touching and being touched by the world. With so many invisible threads holding everything together, it can feel tempting to search endlessly for complete answers. But perhaps the deepest comfort comes not from unravelling every thread, but from recognising that mystery is not an enemy. It is a companion. It is what makes the universe feel spacious rather than mechanical, alive rather than static. Without mystery, the night sky would lose its depth, and curiosity would lose its spark. Think of how stars appear when you lie beneath them. You can name a few: Orion, the Big Dipper, the Southern Cross, but nothing about that knowledge diminishes their wonder. If anything, it gives the night an extra layer of meaning, a quiet invitation to look closer. And yet, beyond the stars, you know lie countless more that you will never see. Galaxies drifting, clusters forming, filaments stretching across unimaginable distances. These distant lights add to the sky's beauty precisely because they are beyond reach. The universe works the same way. The more we learn, the more we see how much remains hidden. Each discovery opens a dozen new questions. Dark matter explains the motion of galaxies, but not its own nature. Dark energy describes the expansion of space, but not its origins. Space-time curves and ripples, but its foundation may lie in quantum threads we have yet to fully understand. Consciousness illuminates our inner world, but its true nature remains softly elusive. Our instruments stretch further each year, yet the horizon of mystery recedes just as quickly. Instead of seeing this as a chase with no finish line, you can imagine it as a walk through a forest at dusk. Each step reveals new trees, new paths, new shapes silhouetted in the fading light. You will never see the entire forest, but the part you can explore is more than enough to stir wonder. The unknown does not block the journey, it deepens it. There is also comfort in knowing that uncertainty has always been part of human experience. For most of history, people lived under skies whose stars they could not explain, surrounded by natural forces they could not name. And yet, they lived fully, dreamed boldly, and found meaning in the patterns they could glimpse. Mystery was not an obstacle to life, it was the backdrop against which life unfolded. Today, even with our scientific tools and telescopes, mystery remains. But it has changed shape. It has become quieter, more subtle, woven into the fine structure of reality rather than looming over daily life. We no longer wonder whether stars are campfires in distant kingdoms. Instead, we wonder how space stretches, how fields vibrate, how consciousness arises, how information shapes existence. The questions are different, but the feeling is the same, the sense of living inside a story larger than ourselves. And perhaps the most soothing truth is this: you do not need to understand every layer of reality to belong in it. You already belong. You're made of atoms forged in ancient stars, shaped by forces older than Earth, sustained by patterns that began long before you were born. The elements in your body were gathered by the pull of dark matter. The time you experience depends on the curves of space beneath your feet. The thoughts you think emerge from the glow of neural patterns, which themselves arise from quantum events billions of times smaller than a grain of sand. You're not separate from the universe's mysteries. You're built from them. Sometimes, when you pause long enough, you can feel this connection. Not as a grand revelation, but as a soft, quiet truth resting beneath everything else. The breath you take, the heartbeat you feel, the thoughts drifting through your mind. Each one is a reminder that you exist inside a web of invisible threads, threads that stretch across galaxies and down into the smallest depths of matter. You're shaped by unseen forces, held by unseen structures, carried by a universe that is both knowable and unknowable. And there is a kind of peace in that. You do not have to solve everything. You do not have to hold the whole cosmos in your mind. It is enough to know that there is always more to explore, more to imagine, more to discover. Mystery gives the universe its depth, its softness, its quiet invitation to keep looking. As you settle into this final reflection, you might imagine yourself floating gently in a vast, dark sea, not alone, but supported by invisible currents, connected to everything around you. You're part of a story still unfolding, still shimmering with questions, still full of wonder. And in that story, your existence is one of its brightest threads.